Welcome to episode 10 of the David Bernard Podcast. Today is June 15th, 2021, and it's a Tuesday, and we are looking at disturbed weather in the far southwestern Gulf of Mexico. Obviously, that's on the top of everyone's minds, and we may see development down there. It's looking more and more likely. What we don't know at this point in time, and remember, this is being recorded on Tuesday the 15th in the afternoon, is exactly where that low-level center is going to develop and where it's going to eventually track. All signs point to it most likely making a landfall somewhere near the Louisiana coast on either side of southeast Louisiana, and that's going to determine really just how bad the weather is here this weekend, possibly as early as Friday night. Like a lot of these June storms, they're sloppy, they're big, and flooding is likely going to be the biggest consequence. Also going on this week, the National Hurricane Conference is in town. So we have members of the National Hurricane Center here, just a couple of them in town, most of them back in Miami, of course, working on the tropics, the rather active tropics, as we have Tropical Storm Bill out there as well. That's currently over the Atlantic, moving out to sea though, and that's not going to be bothering anyone. Remember, you can always watch this podcast if you want to as well. We have a video version on our website, fox8live.com/David. And if you're watching on our website right now, you can always get the audio version on our website, or you can subscribe to my podcast from your favorite podcast apps, wherever you hear all your other podcasts that you listen to. Don't forget, fox8live.com and Fox 8 News and Weather apps also provide live streaming of our newscast. That is particularly important now that we're in the hurricane season. As we saw last year with Zeta, 90% of us in the metropolitan area lost power during Zeta. And so the only way that you might be able to watch us is using your tablets or phones. But you have to have a way to keep them charged. And that's, of course, assuming you're able to maintain your internet connection. But usually the power is going to go out before you're going to lose an internet connection. And if all else fails, you can listen to us on the old-fashioned terrestrial radio stations. We're on the iHeartRadio network. And a lot of people, that's the only way they got information the day after the hurricane hit and Zeta moved through, as they heard us on the radio. Well, today my guest is Dr. Phil Klotzbach of Colorado State University. He's part of the Colorado State University Tropical Weather and Climate Research Division. Colorado State, by way of Dr. Bill Gray, helped to pioneer the science of hurricane season predictions. For many years, you heard us talk about what is Dr. Gray predicting, what is Colorado State predicting. Well, Dr. Klotzbach co-authored the seasonal outlooks with Dr. Gray all the way until 2005, and then he became the lead author. Unfortunately, we lost Dr. Gray in 2016, and Dr. Klotzbach ever since has been heading the forecast efforts. So we're going to hear from him on what we can expect for the rest of the season and talk about climate change and hurricanes and how they could be impacting our situation here along the Gulf Coast in future years. So let's bring in Phil. Dr. Phil Klotzbach, welcome to the podcast.
Thanks so much for having me, David. How are you doing today?
I'm doing great. And from here on out, I'm going to call you Phil because I've known you for a really long time. And so to me, you're just Phil. So we're going to stick with that.
Sounds good. How long have we known each other now? It's got to be like 15 years or so, I would think, at least.
I think it's probably around that time, and at least that amount of time, because I know it goes back to at least Katrina, and maybe even a little bit before that. Right now, you are in, I mentioned to everyone beforehand, you're in New Orleans for the National Hurricane Conference. Now, people would say, who's doing a hurricane conference in New Orleans in June? Well, we moved it, right? It's normally in April, but because of the coronavirus, they thought June would work out better. Of course, if you do it in June in New Orleans, there could be something in the Gulf. And so we kind of have something in the Gulf today, and I guess a lot of my listeners and viewers out there kind of want to get your take on what this might look like over the next couple of days.
Yeah, and there's I can hear a little bit of thunder rumbling even while we're talking here in the hotel room. So yeah, it is June, but I think when it comes to the forecast, I think the National Hurricane Conference made a very good forecast in pushing the conference from April to June. They got a lot more people able to come because of the pushing the forecast. But yeah, when it comes to the system in the Gulf, there is an area of disturbed weather, and it's actually been extremely well forecast. Even the models were even highlighting this area about 10 days ago. And it's kind of slowly getting its act together. I don't think necessarily it's going to be the environment doesn't look super conducive for, a very strong storm, but it looks to be probably a slow moving storm. So it looks like, the Hurricane Center is already highlighting heavy rainfall on the northern Gulf Coast, probably starting as early as Friday, and then lingering through the weekend. So it looks like, not necessarily a big wind threat, surge threat. It's questionable if there's going to be too much surge, but certainly a rainfall threat seems to be the big concerns with the system. Whether it actually formally becomes a tropical storm, or even if it doesn't, it's still going to bring a lot of rain to the northern Gulf the next few days.
Yeah, and that's, of course, what we don't know is the size and the intensity of the storm and the track. Really, the size and the track is going to have everything to do with, where this rain ends up. And I always tell my viewers, look, it's too soon. All we can say is the chance for significant rain in the New Orleans area is increasing, but I don't think we can get much more detail than that.
Correct. Yeah. I mean, the models are still all over the place, and it's hard too because the system hasn't even developed yet. So knowing exactly where the storm is going to develop and then where it tracks is still, I think there's a good consensus that it'll be slow moving, but exactly where it makes landfall and then where it exactly tracks after that is still a question mark because we're still talking Friday, Saturday, Sunday timeframe. So it's still a few days out.
All right, well, let's get into what you do, and that's seasonal hurricane forecasting. June storm, this is not unusual. The climate's about every other year we see a June storm, maybe almost every year if we look at more recent climatology. But more or less, these May storms have been, a lot of people have been talking about all these May storms we've seen. I think it's 6 or 7 years in a row now. We've had what we call a preseason storm before the official start of the hurricane season, June 1st. Is this something, when you're making your hurricane forecast with Colorado State University, is that something that you factor into what the season could look like? If we have a May storm, is that a signal for a busy season?
Yeah, so if you look historically, when you get storms forming in May, June, and even into July, that typically doesn't correlate very well with the rest of the hurricane season activity. That is, whether you have an active May, June, July, or really nothing in May, June, July, it really doesn't say much about how active the rest of the season is likely to be. Really, the only area where it does tip you off typically to a very active season is if you get storm activity forming in the deep tropics. So not in the Gulf of Mexico, farther south, especially anything coming off Africa that develops. It's pretty rare that you get stuff there in June and July, but if you do, that's typically a sign of an extremely active upcoming hurricane season, especially if one of those systems reaches hurricane strength. But, whether this system in the Gulf forms or not, that doesn't necessarily really say anything about how active the rest of the season is likely to be. If you look historically, it's seasons where storms have formed in May, June, and July. There's been plenty of active seasons where almost nothing formed in May, June, and July, and there's been kind of some dud seasons where you got a decent amount of early season storm activity and then not much else.
Okay, so your latest outlook was issued right at the start of the season a couple of weeks ago. Remind us of that forecast, and then when should we expect another update?
Yeah, so that forecast was for an above normal season, 18 storms, which would include Anna and Bill, which have already formed. Of those 18, 8 becoming hurricanes, and of those 8, 4 becoming major Category 3, 4, 5 hurricanes with winds of 111 miles an hour or greater. That compares with the long-term average, which NOAA just updated. It's now the average they use is 1991 to 2020. That average is 14 storms, 7 hurricanes, and 3 majors. So an above normal season, but not to the levels of activity that we saw last year. So I don't need to tell you and your viewers that obviously last year was extremely active, obviously, especially for the state of Louisiana. But in the basin as a whole, we had 30 storms. We all got very familiar with the Greek alphabet, unfortunately, last year. The most storms we had seen in the season prior to 2020 was 2005. We had 28. We broke that record with 30, and we had 14 hurricanes and 7 majors. So a very active season last year. We are expecting an above normal season, but not to the levels of what we saw last year, at least at this point.
And, of course, we're familiar with 2005 here because that was, of course, the Katrina year. Let me ask you, so you're predicting 18 storms, and I've seen you in a lot of your talks. There's a lot of people that do hurricane seasonal forecasting now, and we're going to kind of get into the history of the seasonal forecast with Dr. Bill Gray, Colorado State, and, of course, yourself. But there's a lot of private companies that do it. There's other universities, of course, NOAA. Let's take NOAA. NOAA issues usually like a range for their numbers. You have a specific number. You're saying there's going to be 18 storms. Is there any reason why you give a specific number rather than a range?
Yeah, so when we do our forecast, we give the midpoint, which is our best estimate, but there obviously is uncertainty associated with those forecasts. So while, our best estimate is 8 hurricanes. Obviously, if there's 9 hurricanes or 7 hurricanes, from a seasonal forecaster perspective, I think that's a good forecast if you're off by 1. We do provide an uncertainty range in the forecast itself, which was calculated based on historical errors of the models that we use. But I find with the general public, it's good to kind of focus on your best estimate, because oftentimes when a range is given, sometimes the media will grab onto the high end of the range, and then they'll say, I've seen it happen before where, say, for example, our range for hurricanes this year, we forecast 8, but the range is 6 to 10. If we were to say 6 to 10, I've seen a lot of media say up to 10, which to the general public means 10. So suddenly your high end becomes your forecast. And then it just gets, I think sometimes it's better just to have the one number, similar to the way a lot of times when you do, a day-to-day weather prediction, you'll say the forecast high tomorrow is, 88 degrees. Now, obviously, in Louisiana, the standard deviation is going to be a lot smaller than in, say, Colorado. But, if it's 88, if you forecast 88 and the high is 89 or 87, people probably aren't getting too ticked off. You forecast 88 and the high is 74, they might get a little grumpy. But frankly, if you forecast 88 and the 74, people probably actually really like the 74.
Now, I was going to say, you took my example. That was right what I was going to say, is how we forecast on a daily basis, is that if we're within a couple of degrees, that's considered a good forecast. And by the way, we'll take an 88 this time of year any day.
Yeah. So, and we are working more on probabilistic forecasting, which, depending on kind of who's interested in it, it is nice to have those probabilistic forecasts. And we actually have a pretty rigorous probability of exceeding specific thresholds. So the probability of our forecast is for 8 hurricanes, but there's we have a specific probability of having 10 or more hurricanes, or 11 or more. So you can kind of see how the distribution changes. And again, that's based on the historical errors of the models that we use. So we do try to have some rigorous uncertainty calculations in addition to the number, which is our best estimate.
So let's talk about the month of July. You have some preseason forecasts that you put out. You put out an April forecast. You put out a forecast at the beginning of June, the one we just talked about. And then you'll have another update, as you mentioned, coming out as we get toward the peak of the season. And right now, we're really in a transition time as far as the atmosphere and the ocean as to what this year is going to look like. How important is July from a climate standpoint for what the hurricane season could be?
Yeah, that's a really good question. I think really, it's really the tropical environment tends to lock into whatever mode it's going to be in, usually starting in about late June and through July. So normally with our seasonal forecasts, the stuff that we look at in April and June, we look at some stuff in the tropics, but a lot of the predictors we use aren't even in the tropics. They're in the mid-latitudes. And that's because what happens in the mid-latitudes will then affect the tropics for the peak of the hurricane season. But once you get into July, your climate tends to kind of lock into whatever mode it's going to be in, which is why last year when we put out our August forecast, so right before the hurricane season really ramps up, we really bumped our numbers up because the July environment looked extremely conducive for an active season. We had extremely active West African monsoons, so the systems coming off Africa were very conducive. The waters in the Atlantic were warm. We were headed towards a moderate La Nina event, and especially the vertical wind shear, so that change in wind direction with height in the atmosphere was very low during July, one of the lowest values on record, down with like 2005 and 2010, which were other very active seasons. So we said, okay, this looks like it's going to be, just a gangbusters hurricane season. So ourselves and other groups really bumped the numbers up from June to August. And I think that's one of the things with the seasonal forecast is that you get some skill, modest skill in April, moderate skill in June. By the time you get to August, usually there's very good skill. There are certainly still years where you completely bust, but in general, by the time you get to August, you really do know pretty well what the season is likely to be like. And again, even though you're 2 months into the season, you have over 90% of your major hurricane activity to go. And Bill Gray used to ring a bell every year on August 20th, signaling the active part of the season. And really August 20th to October 10th in general is when you get most of your major hurricane activity. Obviously, last year we had a crazy end of the season where we kept racking up major hurricanes all the way into mid-November.
Well, what's out there right now as far as conditions go versus last year? Like, for instance, the main development region, which is the area of water between the islands and Africa, roughly between 10 degrees latitude and 20 degrees.
Yeah, so right now those water temperatures are near average, so basically right on normal. And also in El Nino, with that other region of the tropical Pacific, the water temperatures there are also right near average. So there's not, if today we're August 20th, and we were really ramping up the season. It'd be pretty much a dead-on average, the Pacific and the Atlantic. But what we're expecting to see is, because the subtropical Atlantic is very warm right now, much warmer than normal. Typically, when you have a warmer subtropical Atlantic, that tends to mean you end up with a weaker subtropical high, which forces weaker winds blowing across the tropical Atlantic. And if you have weaker winds blowing across an ocean, it tends to cause less churning up of the ocean surface. So then the waters in the tropical Atlantic warm. So we haven't seen a ton of that yet. That's kind of what we're expecting to see. That's what statistically and historically, that's the way things have worked. And most models are also forecasting that for the next few weeks. So that's something we're going to be obviously very closely monitoring, because obviously if we're doing the same podcast and it's July 31st as opposed to June 15th, we might have to change the numbers a bit if those waters don't really start to warm up here soon. But at least as of now, there are some indications we might see some warming in the next few weeks.
So I want to talk about the Gulf of Mexico a little bit, because this is no offense to you whatsoever, but a lot of times I have to tell my viewers, look, these forecasts are very important scientific and academic exercises that help us understand the atmosphere better and understand how and why these storms form. Obviously, if you're sitting here along the Gulf Coast, and particularly in the Gulf of Mexico, your forecast is not that important to us. Each year, really, our chance is about equal. I kind of consider the Gulf of Mexico a bit of an outlier. Even in El Nino years, the Gulf doesn't seem to be as influenced negatively by that. Is that what you have found in your research? I mean, it should be treated a little differently.
Yeah, so the Gulf of Mexico, especially in El Nino years early in the season, you still can occasionally get storms. Typically what El Nino really does is it knocks down your late season hurricane activity, whereas La Nina really amplifies it. So last year, which we had a La Nina, we had a very, very active late season, whereas when you have El Nino, normally the October, November storms are much fewer and also generally weaker. But yes, I mean, obviously, when it comes to the Gulf of Mexico, there's unfortunately very low predictability on a seasonal timescale for that region. And that's, I think, somewhat because, so the storms coming off Africa, if the environment isn't conducive, they're not going to form. But the Gulf of Mexico, you get storms forming from a variety of different processes. You'll get storms that come all the way across from Africa, like on Ivan, but you also get storms that blow up farther to the west, or in the Gulf of Mexico itself. And those storms aren't necessarily as driven as, they're not as impacted by what's going on in the deep tropics. They're more governed by local scale conditions. When you get fronts that spin up, especially early and late in the season, those may not necessarily be the same kind of the same overall factors that drive those storms as what you get in the tropical Atlantic. So there's generally very low predictability for that region on a seasonal time scale. Not to say that there isn't good predictability on a shorter time scale. For example, the system in the Gulf of Mexico, I did a podcast with Brian Norcross on June 3rd, and even then we were talking about, the potential for something developing in the Gulf of Mexico in 2 weeks. And I think that's a testament to how, not that these models are perfect, but that there's actual predictability 10 days out for a storm forming. I mean, that's something that, Bill Gray would have loved to have had, I think, in the 50s and 60s. And it's just something, I think, that as technology gets better, as we get better observations, and as the models get better, is something we're going to be able to, not a perfect forecast skill, but at least be able to see these kind of genesis possibilities 10 plus days in advance is really pretty impressive.
Well, we're going to talk about the science behind you make these seasonal forecasts in just a second. But first, a little bit of history. I remember Dr. Gray very fondly. I had many conversations with him over the years, a brilliant mind, and I know how much he meant to you both professionally and personally as one of his understudies and one of his last PhD candidates, I believe. Talk a little bit about your relationship with Dr. Gray and your history with Colorado State.
Yeah, so I've been at Colorado State since 2000. I went in 2000 to go to grad school there, and I've been there for 20 plus years. They haven't kicked me out yet. But yeah, I mean, I had the great privilege of working with Bill Gray from 2000 until 2016 when he passed away. Bill Gray was the founder of the seasonal forecast. Prior to his first seasonal forecast in 1984, there really was no when doing these predictions. And so really the way he got started was he was teaching tropical meteorology, and he knew which years in the past were active hurricane seasons, and he knew which years were El Nino years. He was basically Wikipedia before Wikipedia. And he realized, hey, when you have an El Nino, your hurricane season's quieter. So then he was very curious as to why that would be the case. And so he went through and started discovering how physically why El Nino reduces hurricanes through increases in upper level winds that tear apart hurricanes. And so one of the reasons I think Bill Gray was actually even able to get started with doing these predictions is because he had been in the field at that point for well over 20 years, and he had done a lot of really groundbreaking research on tropical cyclone genesis, structure, intensity change. I mean, his papers, he's best known to the general public for his seasonal forecast, but I think his lasting contributions in things like genesis, especially genesis and structure, are probably even, if I were to rate them from a scientific perspective, probably even more critical, just because these things are fundamental. And still, I mean, his papers are cited thousands of times every year. I mean, yeah, you can't really go anywhere in the field without citing Bill Gray. And he was certainly not only a brilliant scientist. He had over 20 PhD students. I was his last one, 50 master's students, and just a character. I mean, just a really, really colorful character in addition to being a brilliant mind. I'm sure you have many chances to talk with him too. And just he was just brilliant, really, really funny, and just a larger than life personality. He was about 6'5" and just had the personality and the voice to go with it.
And, and I could tell he was someone who never lacked curiosity. He would ask me questions. He was always wanting to know something new.
Yeah, and he really was passionate about forecasting, and so he went into the Air Force in the early 50s, and he was an Air Force weather officer in the Azores Islands, and so he did a lot of forecasting before models, before computers really. So you're doing like hand-drawn weather maps, and so he was always wanting to forecast, whether it was weather, whether it was, if you went to his whiteboard in his office, he had forecasts for, who was going to win the election, who was going to win the Super Bowl, who was going to win the World Series. He always wanted you to predict things. He always wanted you to put predictions and numbers. And so I went to visit Dr. Gray about 4 days before he died, and he was grilling every single doctor and nurse that came into the office, asking him how many more days he had to live. He wanted a forecast from every single person. And so the one guy came in and said, "Hey, I think you're going to get better." And he's like, "I like this guy. You want him, he needs to come back." So it's just, he always was forecasting everything right to the end, and and like you said, just a boundless curiosity. And I think that's really one of the things I enjoyed about working with him, was he always was digging for new ways of forecasting and new avenues for research, and and he passed away at 86, but he was really ticked off that he was dying, because he said, "I've got so many questions I still haven't answered yet. I can't die yet. I have still things I need to answer." So
I think we're all gonna end up at that spot one day. We're never gonna have all our questions answered, but he did answer quite a few for all of us. So let's talk about the seasonal forecast. How has it evolved since his first ones in the 1980s compared to now? Are you using different metrics, different methodologies? Have some things worked, some things not?
Yeah, I mean, we could spend 3 hours talking about this. So when Bill Gray started doing these forecasts in the mid 1980s, computers were around, but they weren't nearly as capable as they are today. So a lot of when he started these forecasts, people were actually sending him individual data from weather stations on paper. Whereas now we use globally gridded data sets. So there's global data sets of things like water temperatures, pressures, atmospheric winds. So that's what we use to basically assess what the state of the climate is now, as well as what the state of the climate has been going back. They have some of these actually going back to the mid-19th century, especially since the late 1970s. They're pretty good because you have global satellite coverage to better estimate some of these things. So most of our models now are built on data over the past 40 plus years. And something that we have now that Bill Gray didn't have access to because they just weren't there yet is climate models. And so what we use climate models to forecast the large-scale environment. And we focus on July. As you talked about earlier, you tend to get really good predictability using the month of July. And if you're using the climate model to forecast, the farther in the future you use the model, the less skill it's going to have. So if you're doing, say, a forecast June 1st and you tell the model forecast July, it's going to generally have better skill than if you say forecast August or September. So we use climate model forecasts of what the environment is going to look like in July. So the water temperatures, the pressures, the winds, and then we use what the climate model says for the month of July, and then use those relationships, how those relationships historically have related to hurricane activity. So those are kind of what's known as a hybrid model. We use a model to forecast the future climate, and then we use those relationships of the climate with hurricane activity. And again, that's something that we didn't have, or that Bill Gray just didn't have in the mid-1980s, because climate models were definitely in their infancy at that point. They really hadn't gotten to the point where they were worth very much, and now they're obviously gotten a lot more skillful. So I think that's an area we're actually really excited about exploring in the future. And I'm downloading climate model forecasts as we do this podcast as well. So we're hoping to have some new. So right now we use the European Center model and the UK Met Office model, but there's a bunch of others out there. So we're downloading some others to kind of. The nice thing is because these climate models forecast. They're forecasting obviously the future, but they have about 25 to 40 years, depending on the model, of historical data, so you can calibrate the model and know how well it actually works, because some models are obviously better than others. And so in the case of a climate model, past performance is usually somewhat at least of a guarantee of future results.
Okay, so and speaking of looking at the past, analogs, is that along the lines of what you're talking about? That's something different, right? I mean, you can well, you explain that.
Yeah, so we also use analogs, which involves going back into the past and looking for years in the past that had conditions most similar to what we currently see and what we expect to see for the peak of the season. And, if you were to ask myself, or you were to ask one of the NOAA seasonal forecasters or some of these other groups doing seasonal prediction and ask them for their analogs, probably some would be the same. I'm sure some would be different. And that's because obviously everyone looks at what you're looking for analogs is probably going to differ a little bit from person to person. But in general, what we do is we look for years in the past that had conditions most similar to what we currently see and what we expect to see for the peak of the hurricane season. So in this case, we selected 6 analog years. Let's see, they were 1996, 2001, 2006, 2008, 2011, and 2017. Now, if you look at those various years, there's a very big spread in activity. You can have a year like 2006, which was a sneaky El Nino, came on much more than I think anyone really thought. And it was a fairly benign season overall. And then obviously 2017 was a super active season for just about everybody. And so that gives you an idea of just kind of the uncertainty there is associated with basically fairly similar sets of climate conditions can generate very different results. But also too, it's June. We don't know exactly how things are going to play out. We think the odds of an El Nino are pretty low, but we did put in 2006 because if we were to have done this podcast in 2006 in June, I would have said the odds of El Nino were also very low, and we still ended up with one. So
obviously the seasonal forecast has come a long way. That's all good news. But things can go wrong. And I may ask you in a minute about what your worst seasonal forecast has been. And I think I know what the answer is going to be. But what are some things that can go wrong that can really impact the forecast in the heart of the season?
Yeah, so there are. So even with perfect knowledge of what the large scale conditions were, so even if you were to say, I can tell you exactly what the water temperatures are going to be like, I can tell you what the shear is going to be like, the moisture, all that stuff. Even with perfect knowledge of the hurricane season, like the large scale environment, you're not going to be able to say exactly how many storms are going to form or how many days are going to last. There's just because you're trying to forecast weather events on climate timescales. So there is uncertainty even when you have perfect knowledge. So not even trying to forecast the season, but even if you know exactly what the large scale environment looked like, there are some years that kind of quote unquote overachieve or underachieve just given the environment that they have. And that's because you can sometimes get storms where the environment in general is fairly harsh, but there's one little pocket where the environment's conducive and that storm will happen to find that environment. And alternatively, oftentimes too, if you get, let's say, a really large in size hurricane, sometimes that can shear off the waves that are coming off Africa behind it. So there is, even with perfect knowledge, there is uncertainty, but also too, especially a forecast issued in June, there's things that can trend differently than the way you expect. So these historical relationships don't always work, and even climate models, or certainly climate models, can also forecast a much more conducive or less conducive environment that would actually happen. So when it comes to seasonal predictions, our biggest forecast bust that I was a part of was 2013. We forecast, I believe in June, we forecast 9 hurricanes, and there ended up being 2. That was about as good as my prediction, I believe, 2 years ago. The San Francisco Giants were going to win the World Series. These forecasts occasionally will be lousy, but in general, the forecasts do show skill. I mean, we've been doing this for 38 years. The fact that people are still paying attention indicates there's some science behind it. And these forecasts, I think, will continue to improve both as we get better historical data sets that give us a better idea of what the history of the hurricane seasons were like, but also as we get better climate models, better forecasts of what the large-scale environment is likely to be like. That will also help to eliminate some of these, especially these really large forecast busts. We've redeveloped models since 2013. Even still, they still forecast more activity than what we got, but now it's forecasting, a little bit below normal season or average season as opposed to, well above average season. So at least that's some improvement.
And and sometimes you can't even explain years like 2013. I mean, I think you would say even to this date, there's some few things that went wrong with the atmosphere that we don't even completely understand.
Yeah, that's correct. So one of the big arguments for 2013 was that we had a lot of basically intrusions of dry air from the middle latitudes, a lot of fronts that came in from the mid latitudes and caused more shear than was expected, and that works to a point. But even if you look at those kinds of indices, they would say, a little bit below normal to near normal, not two hurricanes. I mean, it was extremely quiet, and I think there's just some uncertainty with that. We wrote a paper after 2018, which was more active than we anticipated and NOAA anticipated as well, and tried to basically, again, look at the large-scale environment during the season. And 2018 effectively, quote-unquote, overachieved in that it generated more storms than you would have thought given the environment. In 2013 was basically the opposite. Effectively, the environment wasn't super conducive, but it should have produced more hurricanes than two just given the environment. But again, these are weather events on climate timescales, so when you do a 3-month average, as opposed to looking at individual day by day, you can just happen to have, again, a storm find a pocket of a conducive environment like Florence did in 2018, or you can have a year where the systems just happen to, there may be one harsh area and the rest of the basin's good, but the storm finds the one harsh area and therefore it doesn't develop. So there's always going to be uncertainty with these forecasts. No one's going to be able to give you a perfect seasonal forecast. I'm sure 100 years from now, forecasts will hopefully be a lot better, but you're still going to have uncertainty with those.
And I mean, it's kind of the thing that keeps me going in the business, if you want, to know the truth, is the fact that when we get something wrong or something we don't understand, it just makes me want to understand it that much more. I think back when I started in broadcasting, Phil, in 1992. Okay, so, you're a baby. Okay, I'm a lot older. And my first storm I covered on air was Andrew. I grew up in the Houston area in the 70s and 80s, and really, I was way into weather, but not a lot was happening in the 70s and 80s. There were some notable exceptional storms, and of course, being in Houston, we had Hurricane Alicia in 1983, but then things really took off. And of course, I guess maybe this is for good. When I really first got into TV, we entered what is called the new active period. And it was a new positive phase, warm phase of the AMO, the Atlantic Multi-Decadal Oscillation. Talk a little bit more about that, and of course I'm going to want to ask you about some new developments and some other scientists, their take on the AMO and how important it is to Atlantic activity.
Yeah, so the Atlantic Multi-Decadal Oscillation is basically a natural oceanic circulation that varies on timescales about 25 to 35 years, where the Atlantic tends to be warmer, and then alternatively periods where it tends to be colder. And since 1995, it's generally been warmer. We've had much more active hurricane seasons. If you look back historically, the 70s and 80s, as you mentioned, were generally very quiet. You had some active seasons, or you basically didn't have very many big active seasons in the 70s and 80s. It was generally pretty quiet. You go back from the late 20s to the late 60s, in general, was much more active. 1900 to 25 was likely quieter. The late 1800s were extremely active. We don't have great basin-wide data, but looking at the landfalls, it was extremely active for landfalls. And then likely the 1850s, 60s, 70s were quieter. And then if you go back further, the data really starts to get dodgy, but probably the 20s, 30s, and 40s of the 1800s were much more active again. And so you have this kind of multi-decadal variability in Atlantic hurricane activity. And we think it's primarily, at least I think it's still primarily driven by oceanic circulation. Some others have argued there's a lot more aerosols. Some have argued that there's more volcanic eruptions. But I think the thing that generally they didn't address in these papers is if you look at the changes are very rapid. So from 1969 to 1970, there was a big flip. The Atlantic got a lot colder, and it was over the timescale of just several months. And likewise, 94 to 95, basically the Atlantic flipped a switch, and it went from complete dead hurricane season and very cold water to much, much warmer water. And you see the big changes in the far North Atlantic, where the water temperatures changed by about half a degree to a degree Celsius, which is 1 to 2 degrees Fahrenheit. Doesn't seem big, but that's a big flip. And if it was more aerosol driven, you would expect it to be kind of a slow, gradual increase and decrease, especially when they're arguing things like the Clean Air Act, because it wasn't like the Clean Air Act passed and suddenly the next day everyone said, okay, we're cleaning up our act, there's going to be no more aerosols. It was kind of a slow, gradual process, and the temperature changes are much more rapid and consequently, I think, are more ocean circulation driven than necessarily forcing from just volcanoes and human-induced sulfate aerosols.
Okay, and so I guess just so my listeners know what we're talking about, this is Michael Mann who put this paper out, who actually coined at least the phrase AMO, Atlantic Multi-Decadal Oscillation. He didn't, I guess, recognize it completely, but he claims to have coined it, and so you're right. What he is talking about is he thinks there's not as much of a signal. The AMO isn't as important, or maybe doesn't even exist, and that really what had happened during these downtimes is just what you said: more pollution in the air, more industrialization, and also periods of volcanic activity, which is true. If we look back at the quiet period in the early 20th century, late 19th century, there was increased volcanic activity, as well as in the 60s and 70s and 80s, and then culminating with Mount Pinatubo. But so what you're saying is that we know that has an effect. That we know that has a cooling effect on the atmosphere, but maybe just not the whole thing.
Correct. Yes, and also too, volcanic eruptions cool everywhere. They don't just cool, the Atlantic by themselves. It cools the global tropics. And really, what's important when it comes to active versus inactive Atlantic hurricane seasons isn't necessarily the water temperatures in the Atlantic are important, but it's more relative to the Atlantic relative to the rest of the globe. So one of the reasons why in El Nino years the Atlantic is quieter is because even if the Atlantic's near normal, even a little warmer than normal, the Pacific gets a lot warmer. So you tend to force more upward motion in the Pacific, more sinking motion in the Atlantic, and that tends to really stifle the season, in addition to the increased winds that tearing apart hurricanes. So I think there's a lot more evidence for the ocean circulation being the primary driver. We actually published a paper about a little over 10 years ago now where we showed fluctuations in salinity using early German ship records in the far North Atlantic as far back as 1900. So there's more observational evidence, I think, for this AMO than some people will give credit for. So that's my take. I also don't think that the spatial patterns that were displayed in the Last Man paper really look remotely like what the AMO actually looks like. The climate model just had kind of this broad amorphous warming, and you generally see a bullseye of warmth in the far North Atlantic, which is where you tend to get it's where you tend to get deep water formation, which is probably something we don't really want to get into today. But I think there's a lot more physics going on here, and the ocean circulation definitely has changes on multi-decadal cycles. And that's been pretty well documented in a bunch of papers.
All right, well, so let's go with that and get into the climate change aspect of things. And if we look at 2020, and there were 30 storms in the Atlantic, as we mentioned, it's a record, and many of these were very intense storms. It wasn't just a bunch of little tropical storms being racked up; they were significant storms. And what about, how do you explain the Pacific then? The Pacific, on the other hand, the Western Pacific, and when we talk about the Western Pacific, so people know, we're talking about the typhoons, China, Japan, Vietnam, the Philippines, that area of the Pacific, and the Eastern Pacific and Central Pacific, for that matter, Hawaii, then extending back to off the coast of Mexico. That was really quiet compared to the Atlantic. So why would you have these differences in a, quote, warming world, which we are in, warming oceans overall? Wouldn't you see all basins rise together?
Yeah, and so that's a really good point. So in general, in a La Nina year, the Atlantic activity goes up. You get less shear, but you tend to get more shear in the Pacific Ocean, and so you get fewer storms there, and you generally get a lot less of what's known as this index called accumulated cyclone energy, which is an index counting for frequency, intensity, and duration of storms. So think Hurricane Irma. Extremely long-lived major hurricane generates a tremendous amount of ACE. So in a La Nina year, you generally get fewer hurricanes in the eastern North Pacific, so basically from the west coast of Mexico to the international date line. Last year we ended up with 3 hurricanes in the eastern North Pacific. That's well below its normal. In the western North Pacific in general, in La Nina years, you tend to have a weaker monsoon trough. So you tend to get more storms forming farther to the west. And so you get fewer of the long track storms. So you generally get less ACE there too. So last year in general, while the Atlantic was crazy, worldwide, the ACE was actually below normal. And that's because the Atlantic Ocean is not nearly as big as the Pacific Ocean. There's just a whole lot more kind of ACE potential in the Pacific than there is in the Atlantic. The Atlantic season is also very peak. You really only have, last season, obviously we extended it well into November, but normally it's between about mid-August and mid-October. So when it comes to year-to-year variability, El Nino, La Nina is a huge driver. And if you look since 1990, in general, the environment has actually trended more towards a La Nina-like basic state. So we've had La Ninas and El Ninos, but in general, La Ninas have tended to dominate the last 15 years compared with the previous 15 years. So while the Atlantic's been active, the Pacific's been quieter. So when you look at things like global ACE, it's actually been trending downward over the last 30 years. However, when it comes to climate change, we don't necessarily expect to see more hurricanes in the future. It's just basically that the highest intensity hurricanes, basically the odds of any hurricane forming reaching a high intensity like a category 4 or 5 is more likely to increase. And that's kind of what we're seeing. Isn't necessarily more storms or even more hurricanes. It's just that the high end storms, the chances of hitting those thresholds is higher. But I personally think, well, everyone kind of focuses a lot on, are the storms going to get stronger from a wind perspective? I think for me, the biggest concerns I have is background sea level rising. That's very bad because obviously the background sea level is higher. Even if the storm doesn't change at all, that means an increased inundation from storms. So basically when the storm surge comes on shore, it can go farther inland. But also, as you warm the atmosphere, it just means it can hold more moisture and you just see more heavy rainfall from storms. And there's a whole lot of other questions with climate change, whether storms are going to move slower, whether storms are going to move farther poleward. We could spend, the next 6 hours talking about all of these questions. But to me, when I talk about climate change, I try to focus on the water threat because I think that is something we can, first of all, is more tangible. We already observe it, whereas hurricane intensity and changes on that, we may be seeing some signs of it now, but a lot of it is this, that we don't have we can only observe globally hurricanes, so not the Atlantic, but globally hurricanes well for about 30 years. And that's just a short time period to observe too much of large-scale trends, just given the natural variability in the climate system. So, for example, the last 30 years, we've generally trended more towards a La Nina. So maybe, ACE globally has trended downward, but maybe that's probably not going to continue forever. We'll probably go back towards, more El Ninos, fewer La Ninas, and then maybe we'll start seeing some of these other indices really ramping up.
Yeah, and that's what I was going to say. If you look over a timeline, you're saying 30 years. I guess I've read maybe you could maybe stretch it to 50 years. As far as observation, but there hasn't been a huge trend one way or the other. It's mainly the intense cyclones, I think, is what the focus on. I think Kerry Emanuel that's what he's focused a lot of his research on.
Yeah, and so that's kind of where the question lies. And so the thing with climate change is it's a sticky issue because, people think, okay, you warm the ocean surface, more fuel for storms, therefore more hurricanes, stronger hurricanes. And if all we did was warm the ocean surface and didn't change the atmosphere at all, sure. But when you have climate change, you warm not only at the surface, you warm at 5,000 feet, 10,000 feet, 20,000 feet. And so you warm the atmosphere, and that tends to stabilize the atmosphere, which is a negative for hurricanes. It tends to suppress them. So overall, the surface warming probably dominates, or basically probably kind of trumps the upper atmosphere warming, but it's not a super strong signal. And then also one of the big things we don't know with climate change is, are we going to be in a more El Nino-like basic state or a La Nina-like basic state? And that has huge impacts potentially that may be dominant over any overall climate change warming. So I think we can be much more confident about the sea level rise. We already observe that, and the warmer atmosphere holding more rainfall. We already observe more intense 1 hourly downpours, things along those lines. You're already seeing that. So I think we can be much more confident on that than on, are the storms themselves going to get stronger? The answer, probably yes, but probably not, an enormous increase. But again, even if they don't change at all in strength, just the fact that they're wetter and have higher, then you have a background sea level that's higher, that can obviously cause increases in damage.
And we know storm surge and rainfall, that's where we have a lot of the problems with hurricanes. I'm going to switch gears now for a minute. A lot of my viewers and listeners out there, I think they know this, but they've heard of the Saffir-Simpson wind scale. And up until recently, they correlated a Category 1 storm's winds with a certain storm surge. And as we have learned, that isn't always the case because it depends where the hurricane's sitting. Hurricanes that hit Louisiana, the Texas coastline, really anywhere along the northern Gulf Coast, a Category 1-2 storm is going to produce a much different surge than one that's going to hit the southeast coast of Florida, say Miami or Fort Lauderdale. So now it's just a Saffir-Simpson wind scale. We've pulled the surge out of it. I want to talk about major hurricane landfalls, and we're going to get into categorizing them based on pressure. Okay, and I heard you speak about this at the conference yesterday. We went 11, almost 12 years without a major hurricane hitting the United States. We had Hurricane Wilma. That was the last major in 2005 to hit South Florida. And it wasn't until Harvey in 2016 that we had a Category 3 or stronger strike the United States. Did that break the record, or did it tie the record for one other? I can't remember, but it
did actually break the record because we went from Wilma in 2005 to Harvey in 2017 with no landfalling major hurricanes. But we did have, obviously, several significant hurricanes during that time that were very large. And so I think there was a big pushback against the Saffir-Simpson hurricane, or the Saffir-Simpson scale. Probably, I think Katrina was one of them, because Katrina was a very, very large storm. And so while it was classified as a Category 3 at landfall, obviously we all know what happened in New Orleans. But the storm surge in Mississippi was phenomenal. I mean, you had over 25 plus feet of storm surge. And so there was kind of a big pushback, and especially storms like Hurricane Ike in 2008, which also had an enormous storm surge, and it was a Category 2 storm. These larger storms, like Sandy up in New Jersey, these larger storms, I think, kind of got a pushback against the Saffir-Simpson scale. And so that's why we argued that we wanted to consider using pressure to categorize hurricanes, because while wind obviously tells you the max wind, pressure gives you an overall better indicator of kind of the overall strength of the storm. So not just the max intensity, but the overall strength of the storm. So hurricanes,
the energy associated with it.
Yeah. So it's more akin to the energy of the storm. So a hurricane, the winds are there because there's a gradient in pressure. So you have the pressure at the center of the hurricane in the eye, which is your lowest pressure. And then you have the pressure of just kind of the ambient environment, so away from the storm. And so the reason that there's wind is because the wind is trying to equalize that pressure. So the stronger, so basically the lower the pressure, basically the stronger the storm. And so if you have a very small storm, the pressure can be relatively high because it's spread out over a small area. So the gradient can be. So when you have low pressure, if you have a small storm, you can have a relatively high pressure for the same, for a specific wind speed. So basically, if you have two storms, they have the same wind speed, the pressure of the one is lower, it's generally going to be a larger storm. So in the case of a Hurricane Katrina, we basically categorized hurricanes using pressure as opposed to wind. And so Katrina, instead of being a 3 by wind, by pressure, was a Category 5. On average, about 5% of all storms named by 4% of all storms named by the National Hurricane Center become a Category 5, and about 4% of a pressure below 925 hectopascal or 925 hectopascals or lower. And so Katrina was a 5. Likewise, Hurricane Sandy was a 1 by wind, but by pressure it was a Category 4 because it was so large and had an enormous storm surge associated with it.
So really, I mean, basically, I think where we're heading and where we should head is just an entirely new way of classifying hurricanes, and one that really needs to depend on where the storm is hitting, whether this is a Louisiana storm, whether this is a South Florida, Miami storm, based on the size, the pressure, all of those things, and really come up with a new rating scale.
That's correct. And so we're arguing that, for simplicity's sake, if we're going to use one number, we should use pressure as opposed to wind because it correlates better with damage. We showed historically over 120 years that it correlated better with the damage from storms, correlated better with the fatalities from the storms, correlates better with the size of the storm. And it's also just much, much easier to measure when you're flying a hurricane hunter aircraft and trying to measure the strongest winds in a hurricane. There's really just no way. It's extremely hard to know exactly where those strongest winds are going to be. And to actually measure the strongest winds in a hurricane, which is this broad swath of wind, trying to figure out exactly where those strongest winds are going to be is extremely challenging. Whereas pressure, you fly a plane through the hurricane, you drop a sonde in the eye, you have the pressure. Also on land, it's much, much easier to measure on land. Anemometers chronically fail. Also, too, the National Hurricane Center defines the max wind to be the 10-meter wind in open exposure. And the second a storm makes landfall, that no longer exists because of friction once a storm hits the coast. Whereas pressure, you don't even need to measure. If you want to know the pressure at landfall, the barometer doesn't even need to be outside. You can have it in a building somewhere and still measure an accurate pressure. So that's basically, we're arguing if you're going to use one number that we should use pressure. But obviously, there's more to it than just that number. Obviously, like you said, it's where it's making landfall obviously is a huge impact in terms of how much storm surge you're going to see even for the same pressure. Likewise, a storm moving slower is probably going to bring more rainfall. If there's interacting with a mid-latitude system or there's topography, that can also amp up rainfall. So, the Hurricane Center is really focusing more on impacts, which I think is very good. But I think it certainly still helps to have kind of one number to categorize hurricanes. And I think if we're going to do one number, that we should use pressure as opposed to wind, because it's easier to measure, correlates better with damage, correlates better with fatalities, and I think correlates better with the overall impacts you're likely to see.
I mean, do you think, just real quickly, for instance, if you had the exact same storm hitting Louisiana and one, let's say, that's hitting Broward County and the Palm Beach area, which has a much lower threshold or higher threshold for surge. It's hard to get a major surge into that part of the Florida coastline. Could you see that storm having two different ratings, even if they had the same pressure, or is that getting too subjective?
I think it would probably be a little too subjective. I mean, because the thing is, it's more than, obviously the surge is critical, but it's also the size of the storm. So yes, the storm surge, all else being equal, is going to be worse in Louisiana or on the west coast of Florida than on the east coast of Florida for the same storm size. But a larger storm is also going to have just a larger wind footprint associated with it. So if you have a small category, or like Charlie is a good example, a category 4, it was tiny, so it didn't have much surge, and it was also, where it hit, it did a lot of damage, but where it hit, basically the area of damage that was damaged was fairly small, whereas obviously a storm like Katrina, or some of these larger hurricanes like Ike had a much, much wider area of wind damage. So I think for simplicity's sake, you'd probably just want to keep it the same, because then it would get very because basically, obviously, like the east coast of Florida versus the west coast of Florida, it can be very subtle, not necessarily a huge track changes to cause it to make landfall in a different area with a very, very different storm surge likelihood. Like you said, southeast Florida, surge, you can get some storm surge there, but the storm surge, all else being equal, is going to be much less on the east coast of Florida than on the west coast of Florida, where you can get, that is extremely storm surge prone. Likewise, Louisiana is also quite storm surge prone.
All right, here comes the fun part of the podcast, and I meant to warn you about this, but I think you're going to be able to handle it just fine. First of all, Phil, I'm going to ask you the question, when did you know you were a weather geek? Did you have a moment?
Yeah, so I basically, as long as I can remember, I've been obsessed with the weather since I was a little kid. You could ask my parents. I used to have my dad print out like blank maps of the United States, and I draw fronts on them. I used to watch AM weather on PBS at like 6 years old at 5:30 in the morning. So I've always been just a weather geek. One of the things that really got me into hurricanes specifically was in 1985, Hurricane Gloria made landfall in Connecticut, and I grew up in southeastern Massachusetts, but it still brought pretty significant impacts to our area. And so that really got me interested in more hurricanes specifically. And then basically I went, and as an undergraduate student, I was very interested in the weather, but what really got me into hurricanes specifically, I was taking a climatology class as an undergraduate, and my professor said, hey, you should check out this guy who does seasonal hurricane prediction. I was like, that's crazy. You can't predict a hurricane season months in advance. That's nuts. And then I started reading his papers, and I ended up actually doing my undergraduate honors thesis on seasonal hurricane prediction, and then went off to CSU to graduate school. So, but I've always been really obsessed with the weather, and kind of like Bill Gray, just a curiosity. So I don't claim to be like Bill Gray in many ways, but at least in terms of curiosity, always trying to figure out, what makes the weather, like, why is it going to be sunny today? Why is it going to rain tomorrow? Just trying to figure out what makes the atmosphere tick.
Okay, and the final question is, and people ask me this all the time, but obviously we know that all research institutions, no matter where they are, they have all kinds of departments studying all kinds of sciences and history, whatever it is. And people say Colorado State, they study hurricanes. I'm like, yeah, they study hurricanes, but Even more interesting than that is the fact you live in Colorado and you study hurricanes, but you love the mountains. You are way into the mountains and hiking. Every time I look at your Twitter feed, you're on top of, you're thousands of feet up in the air. The highest we ever get in New Orleans is 10 or 12 feet, unless we're in the upper sections of the dome at the Superdome watching the Saints game. Tell me real quickly about some of your hiking adventures.
Yeah, so I've always loved being outside, and I think that often comes with being a meteorologist. I really like being outside because that's where the weather is. But, I've always been obsessed with hiking. So I thru-hiked the Appalachian Trail from Georgia to Maine in 2002, which is about 2,100 miles. In Colorado, I've climbed all the 14,000-foot peaks. There's 54 of them. I love to run, but basically love to run, hike, play in the mountains as much as possible. And Bill Gray also was a really, really avid hiker. And just spend a lot of time in the mountains. And he used to always say you get your best thoughts, when you're up at high altitude, you're starting to go hypoxic. That's when you get your best thinking done. And even his supervisor, Herbert Reel, who was a really a groundbreaking meteorologist as well, he also was obsessed with the mountains and climbing. So I think there's a lot of there's a lot of good thinking you can get done when you're climbing in the mountains, and it also helps sharpen your weather forecasting skills, because if you especially if you're hanging out in the mountains past about 11 a.m. or noon, things can get very exciting very quickly. So you always got to keep a weather eye to the sky when you're climbing the mountains in Colorado.
All right. Well, obviously, I need to do more trips to Colorado to sharpen my forecasting skills and get out of the swamp on an occasion. So I'll definitely take that advice. I appreciate it, Phil. Thank you so much for coming on the podcast. Glad you're in New Orleans this week, and hopefully you get out of here before we get any weather that's too bad by the weekend.
Sounds good. Heading out Thursday morning, so I think I'll just make it.
All right. Thanks again.
Thank you.
Looks like the one thing we can take away from our discussion with Phil is that it's going to be another busy hurricane season in the Atlantic. The question is, how busy is the Gulf going to be? That we don't know. We always know we have to prepare, of course, for that one storm. Some really interesting insights from Dr. Klotzbach about how we might reclassify hurricanes based more on pressure than just wind. Just like now we're kind of separating that Saffir-Simpson scale from wind and surge. They're really two separate entities and tell two separate stories about hurricanes. And then long-term climate change, it's pretty clear at least that the warming oceans, while we may not get more hurricanes, more intense hurricanes are likely going to be on the horizon. Remember to keep it here on Fox 8 and fox8live.com all week long as the system in the Gulf develops. We'll be updating you 24 hours a day. You can always count on your weather authority for the very latest. Could get quite stormy this weekend. And again, it looks like the biggest threat for parts of our region along the Gulf Coast is going to be heavy rain and flooding. Stay safe, everyone, and I'll see you back here next time.